In this video, we will study the ring counter. In previous videos, we considered the construction of binary counters. In these next videos, we will consider one application of counters to produce a repeating sequence of outputs. When used in this way, the counter can be called a state counter. We will begin with the simplest state counter, called the ring counter. The ring counter does not follow a binary counting sequence. It is basically a shift register. A shift register consists of a chain of D-type flip-flops. To form the chain, the Q output of each flip-flop is fed into the D input of the next flip-flop to the right. In the ring counter, this chain is turned into a ring by feeding the Q output of the rightmost flip-flop back into the D input of the leftmost flip-flop. Thus, with every clock pulse, data will cycle around the flip-flops in a closed loop. When used as a state counter, the ring counter is initialized by placing a 1 in the leftmost flip-flop and zeros in all of the other flip-flops. This is achieved by connecting a manual preset input to the asynchronous set and reset inputs of the individual flip-flops. Specifically, this connection is made to the asynchronous set input of the first flip-flop and the asynchronous reset input of all of the other flip-flops. Thus, activating the manual preset will force a 1 into the first leftmost flip-flop and zeros into all of the other flip-flops. The manual preset is then deactivated. The 1 that was loaded into the first flip-flop will then cycle around the ring counter, advancing 1 flip-flop with each clock pulse.